Director of GBS Energy Limited and former Vice President of Texmaco Metals and many organizations. He has served and executed so many challenging projects in different segments, different cross sections of industry. So I would request Mr. Ghosh to kindly deliver his address.
Thank you very much. The topic is civil and structural design and site execution of machine. I would like to let somebody to the slide.
Actually, your audio is poor.
Audio is clear?
Yeah, Amitava Ghosh, কাছে থেকে বলতে হবে. Your audio is poor.
Now it is clear?
Yeah, now it is much better.
Okay. Okay, next. This is, yeah. So the first point is issue. Any engineering project, plant and equipment are required to be supported on steel work and civil work. All transferring plant and equipment loading finally to foundation and mother work. Next. This is a reverse working. In sequence of site work, civil and steel work to be done first, and then come plant and equipment. But the design of civil and structural work can be done only after getting equipment load done. So design work comes last, but site work comes first. This is the reverse way it happens. In most of the projects, share of civil and steel workforce varies. The thermal it may be 25%, or even hydro project it may be 65 to 70% of the cost of the project. Next. Yeah, this is the thing. So design usually, in an engineering project, particularly in EPC contract or in a turnkey work, civil and structural steel work plays an important role, but we often comparatively neglected it. It needs high level of knowledge and data time to assess in the beginning the quantity of civil and steel work during tender estimation stage to ensure safe and cost-effective design of project. Next. Yeah. In most cases, this gray area leads to quantity, cost, and time overrun. Hence, it is very risky in EPC project where civil and steel of price are on lump sum basis and not on rate contract. It is on lump sum basis. Because the whole calculation goes wrong during execution. And this is the reason why a lot of EPC contractors are in serious problems during execution or at the end of the project. Another point is the steel price. Very, very unpredictable. I mean, one has to be an astrologer to know what will be the steel price during the period of execution of the project. So this unpredictable steel price rise results in increase in project cost. And particularly, there are a lot of projects, big projects, where the price is based on fixed price contract, not on installation basis. So there is serious effect happen on the contract towards the price level or the cost level. Next. Follow. Next. Yeah. In view of above, equipment suppliers lot of equipment suppliers now want to restrict their scope to engineering, supply, and erection commissioning, excluding civil and steel. They are no longer doing so-called EPC contracts. Now, what is the solution? If somebody has to do the EPC contract, then first is meticulous assessment of bill of quantity and estimation in the beginning. And that estimation should be always cross-checked by the second or third party for a set. I'll give an example. This is a tender we were doing for the GST modernization, raw material and handling complex, RMS. That was a very big project. And we had a consultant, renowned consultant, and who did the assessment of bill of quantity of civil and structural. And they made a quantity, steel was 16,000 tons and concrete was 84,000 meters. So after we submitted the bid, we had a discussion with the consultant of the customer, that is bid of the steel. And their consultant says that your quantity is very high. I mean, I'm sorry, we bought in a hard figure, we said 24,000 tons, and consultant of customer said 16,000 tons. The difference is more than 30%. And so is the quantity. We did 1,20,000 meters. They said 84,000 meters. Consultant of big office people. I'm talking Mohan. Mohan said no, the quantity should be much less. And our consulting was a very eminent consulting. And we, the poor EPC contractor, what we do? So both are fighting and they both are saying they are right. And we have to get the order also. So we engage the third party. So they say that whatever Mohan is telling, that lower figure is more or less correct. So we take a conscious decision. We increase 10% high. 15,000 is made 70,600. And we did, and then we got the order. And then the steel company could not give an order because they did not agree. So we did our own and we got that figure also, 17,600 tons. But later again redesigning, we came near about that figure. So this is a risk, actually, that it happens in a big picture. And another thing is that optimization of steel work we do on a continuous basis. Till the commission. I mean, it's not that we design the whole plan and that is the Bible. No. We designed the plan and then we did some part of work and balance part of work we continue finding out whether we can reduce the weight there. So thereby we can do a optimization on a continuous basis. Next one. Hello, next. Yeah. Now I will tell something more about the optimization also. This optimization, of course, optimization reduction of weight will have positive effects on cost of all downstream activities. I mean, you see the top part. Cost is quantity multiplied by weight. With weight, we discuss always about the weight, but you see the quantity is only we can reduce. That reduction will have cascading effects on cost of all downstream activities, material, fabrication, manufacturing, inspection, transportation, erection, and commissioning. And on a very rough estimate, 5% reduction in steel weight in India will result in saving of around 50,000 crore. Now, I will talk something more on the optimization. And how do we do the optimization? See, there are few factors where if we adopt, we can do the optimization. First of all, the concept. We can have a concept. By concept itself, the weight can reduce. Like, there are two tall towers. If we join at the top, then the total weight will reduce. This is concept. Next is the loading. When you consider the loading, sometimes you take too much on higher side, which is not there. So there we can do the correct loading. Third is of course the method of calculation. Latest technique or software we use, then there is a possibility that we can reduce that. And next is stress level and factor of stress. I can compare to the permissible stress level, I can go even up to 99%. No problem. But usually we keep a cushion. And that cushion depends on the designer to designer to vary. Somebody keep 20% and 25%, now 50%. There we can take a judgment and go up to higher. The factor of safety can be replaced. Comparatively within a framework. Next is choice of material. We can go have different type of material, stainless steel, aluminum. Instead of steel, we can reduce it. And another next is selection of sections of stainless. There also, instead of roll section, if you do place a box gutter, there will be some more work, but it will reduce the weight. And also selection of thickness, like 12 feet. In our country, after 12, it is only 16, but in foreign countries, we get 14. There also, the weight difference happens. And finally, most important is the field factor. This comes with a long years of experience, with proven track record. That what should be the factor of safety, what should be the thing we take on this. This comes with the years of experience, because otherwise the process of design is set, whether the design is novice or design is expert. There is no difference. So this is the 7 factors which we have the optimization. And lastly, there is no expiry date of weight optimization. It is a continuous basis. So I think this is all I can say. This is all I would like to say, and I will open a question after the question.
A very lucid presentation by Mr. Ghosh. Absolutely gem from a person who has shared his vast experience in the field of project management and execution. And I would request the members of the audience to reserve their questions, and so that we can take up all the questions at the end of the session. And meanwhile, may I request our next speaker, Mr. Amal Sengupta, to kindly be on board and deliver his address.
Okay. Good evening to all. I am Amal Sengupta, a consultant of mineral processing and material handling system. Yes. My specialization is coal handling plant. Today's agenda is project management and execution at site. My focus is project management and execution of material handling plant. Engineering is the main focus on project economics. The role of project manager to control design, engineering, technology. The project depends on objectives of the system. The compactness of this methodology is upgrade India to a new height. Accordingly, the main objectives and focus are set on conception of cost engineering and time management, challenges for on-time execution and effective monitoring,
পল্লব
and
স্লাইড
case
স্ক্রল
study
করো
and case study for coal handling plant. EPC project is one contract of multidisciplinary assignment in single window responsibility. Engineering starts from mechanical, electrical, structural, and civil, but the execution at site starts in reverse direction from civil, structural, mechanical to electrical. Project execution by parallel activities for on-time delivery and completion needs continual value engineering review and lesson learned. Steel is the main item for equipment, structure, and construction. So monitoring cost and quantity of steel by reverse engineering in continual process is must for project viability due to the price increase in time from start to end of the project. The cost and time improve significantly from ancient engineering to the present engineering due to advancement of technology. In project management, time is the essence and critical resource. Engineering is the key element and foundation of the project. The challenges for on-time execution: engineering, procurement, risk and opportunity, construction, erection and commissioning. And challenges for effective monitoring and management is systematic application of the processes, team member of their talent, utilization of risk and opportunity, communication, friendly relationship with all, site management. And finally, the project organization of many different skills from engineering to the handover of site. And they are the main potential member of the project manager. So the responsibility of project manager is identify all the potential team members and nurturing them for development of their skill from existing role to the next role of the project manager. All the challenges and fundamental questions on effective cost control are mainly on-time engineering, on-time delivery, and on-time completion of the project. And all those items are in details elaborated in my slides, as I am talking very briefly due to the time constraint. Next, 10 commandments of the project management. Involve the project manager from tender stage. Listen and enroll the customer. Know the contract inside out. Build the dream team. Learn about previous experience. Manage the risk. Boost the cash flow. Provide float at the back end. Engineer simply and repetitively. Design for easy construction. Essential gospel of the projects are mainly proverbs, and those are all elaborated in this slide. Technology is in continual improvement and advancing, so each application of particular project is really a learning experience while complete the execution successfully. Project management should be multi-layered, parallel activities reflecting the integration of technology. Crisis execution often needs by cash program for on-time completion in 3 steps to resolve. Number 1, deployment of heavy equipment. Number 2, drawings are not in approval category but only information category. And number 3, at site, all the site member and the site people should listen the project manager only. Typically, this key knowledge related dimension in the business as know how, know who, know what, know when, and know where, which are important for ensuring the technological products and services to be synchronized effectively for any particular objective. Now, case study, coal handling plan. Coal handling plan from concept to commissioning in greenfield and brownfield, including augmentation, executed both in India and abroad, and all are satisfactorily operating. Based on the experience from engineering to execution of material handling plant, the slides are prepared for the new generation to execute the material handling projects in future effectively. Case study is in general, not particular project. Basically, coal handling plant for thermal power plant and coal preparation plant in steel plant. The project work, automation and augmentation. Background is customer was exploring integrated automation solution for increasing the capacity and productivity of the plants to meet their higher demand for coal handling. Augmentation and automation as a tactics to augment the profit and unnecessary unnecessary non-value added cost and expenses. The maintenance plays a pivotal role in achievement of the strategic objective of an organization. Previously, maintenance was considered as an expense to the organization and executed under emergency and breakdown only. But nowadays, maintenance is an investment and proactive of revenue generation of the organization. So automation and augmentation with modification are essential for enhancement of plants in India due to all established plants, and the old age technology needs upgradation to make them at par with the global market. The implementation, the entire project was divided into 4 systems: wagon control system, conveyor control system, crushing and screening system, then fault annunciation system. Methodology, capacity enhancement, adding sizing, crushing and sizing of coal by crushing and screening, adding blending and storage in stockware and silo for different coal, increasing the belt width of existing conveyor system, converting single to double steam operation for either or, and standby equipment use for the entire plant. The methodology of automation is programmable logic control system. The system was designed using ultrasonic level device for measurement, mass flow meter for ensuring accurate flow measurement, pressure sensor to control the axis of all equipment. Advanced chute design with high valley angle to minimize overflow, spillage and jamming of the plant. The full system is ensure trouble-free maintenance and smooth operation of the entire coal handling plant with total automation system. Outcome, direct exact position of fault, calibrate all operations, faster real-time decision-making environment, automation by PLC system, reducing the operation and maintenance manpower. In highly competitive business, every company thrives to increase its overall production and capacity and the profit. Manpower for operation and maintenance related cost contribute major expenses in the business. Therefore, require automation and augmentation by modification for enhancement of the plant capacity. Operation and maintenance activities share significant cost. So, reducing the maintenance cost by automation can improve the profitability. Reduction in operation and maintenance cost effectively reducing the cost of non-value added activities and expenses. Operation and maintenance by manpower is critical in world-class manufacturing unit. So, to achieve world-class performance, operation and maintenance strategies should be linked with the manufacturing strategies with lowering the cost concept. Hence, by applying an effective maintenance strategy, the plant can be ensured with a high degree utilization, reliability, and availability of the equipment for production facilities, especially in continuous operation process like coal handling plant. Automation and augmentation provides an opportunity with advanced technology to enhance the production. Moreover, it promotes the culture of continuous improvement. So there is a need to develop an effective process by automation to collectively integrate and customize the production enhancement into the optimum availability. Hence, automation, operation and maintenance are related to each other with long-term strategic respectively and for continuous production unit. Now I conclude in totality that long-term vision together with the proven and experienced knowledge is most important. Presently, software has an important role to play in supporting the application for effective execution of any project with optimum cost, quality and time. However, software alone cannot deliver correctly all the eventuality and needs to be integrated with human aspect for development of expertise knowledge based platform to serve the industries. Our technical team in GBS are supportive with powerful solution based on their practical field experience, retired technocrats and expertise for any customer specific project in technological industries from its concept to commissioning. Thereby, it can be synchronized effectively in the field of engineering and technological industries for continual development world, but always keeping in the mind that scientists study the world as it is and engineers create the world that has never been. Thank you.
Thank you, Mr. Sengupta. It is really great to hear from you, who is a subject matter expert in the domain of coal handling plant and material handling, and requesting you, sir, to be with us so that we can take up the questions after the panel, all the lectures of all the panelists is over. So, may I now request our next speaker, Mr. Manash Mohan Ghosh, who is joining us, who has joined us from the US. Oh, sorry. He's from. He has joined from India, and Mr. Manash Mohan Ghosh, he is from INSDAG. He is a consultant, and he is from INSDAG. May I now request Mr. Ghosh to kindly deliver his address?
Yes, sir. Can you share my PPT?
Yes, of course. Pallab, can you please help? Yeah, that's it. Yeah, Mr. Ghosh. Please carry on.
Full screen, please. Yeah. Good evening to all. We were discussing on the topic project management and execution. So my presentation will be short, but I will be focusing on some of the issues which I feel is very much predominant in this modern world. So next slide. When we think of any project at this moment, the things which we have to take care of is sustainability. That is what has been the driving force in the future projects, where we have to take care of the people, take care of the planet, and also take care of the business, that is with a motive of profit. So with these three, we are into the decade where we should think of the projects. So this is a typical picture of a coal handling plant, which is carrying coal, lump size coal. So the sides are open. Only the roof has a covering. Next one. This one again is a coal handling plant, but it has covers on all the sides, meaning that the material which is being transferred or being carried is smaller in size and might be coke also. So these are typical views of a typical coal handling plant. So next slide, please. So what is the purpose? What is a material handling plant? It transfers the coal from input point, perhaps coming from any other source or any other site, and transfers it to the charging or the discharge point. So it has to travel from the ground level or below the ground level to a certain point where it is discharging it or charging a furnace or any equipment. So this is the total traveling or the movement of the raw material from one point to the other. So the total scheme for this is called the material handling system. We find coal handling plants in many of the plants, but very much specific or very much important when it comes to thermal power plant, where most of our power plants in India are thermal based, coal based. So coal handling plants in those areas are very much important, very much seen. Similar is the case for steel plants, where the BOF route or the blast furnace route has an input or a raw material which is coal or coke. So there also a CHP or a coal handling plant is very, very important and forms a major part of the total project. Next slide, please. So now coming into the civil and structural aspect of this coal handling plant, the civil or the structural part are the supporting parts. Most of the items are either mechanical or electrical. So what are the items which fall under the scope of structural items and civil items? The trestles. It is a combination of 2 and 4-legged. The conveyor galleries, the maintenance walkways besides the conveyor galleries, catwalks at certain times, catways, the VG2 structures, the vertical gravity take-up structures, which might be 4-legged structures, which actually tightens the belt of the conveyor, or even in certain cases, the HG2, the horizontal gravity take-up structures. Those structural part is the part of the structural engineering department. Junction houses, wherever there is a change in the direction of the conveyor, junction house are prepared, are constructed from where the direction changes. Hoppers, the feeding hoppers, as well as the discharge hoppers, the loading hoppers, etc., are the main items of structural scope in a coal handling plant. And the rest in the civil, most of them are the foundations for all the structures which we have mentioned or listed just now. Next slide, please. Project estimate. There are cost direct, and that is what we come to calculate in a project when we estimate the material handling system of a project. So what is the process? First is in the structural cost. The quantity or volume are calculated based on certain thumb rules, based on previous projects, based on various other sources. So when a quantity is established, perhaps it cannot be definite and true, but it lies within a range. It is multiplied by the unit rate or a cost, sometimes in unit rate, sometimes in lump sum, but unit rate is most effective than the lump sum ones. And the third aspect is the time. The time or the sequence or the time schedule is the other thing which is estimated during the project estimation stage. These all falls under the direct cost. Next slide, please. So now what we find, basically, there are certain items, mechanical items, which are the hoppers, bunkers, chutes, idlers, belts, etc. Next one is the electrical and instrumentation items, the power systems, etc. And the third is the civil and structural items. So there are basically three departments working in tandem to complete or to estimate and complete a project. The mechanical department, followed by electrical or instrumentation, or I should not say followed by, it's a parallel activity. And third is the civil and structural department. Next one. So what happens when we calculate the estimate? What we find that the mechanical items are the majority in quantity. Mechanical items are the majority in quantity, and the cost of the project, 60 to 70% of the total project cost, is governed by the mechanical items. In the other fashion, these items of mechanical uses are quite standardized. Thus, the quantities and the total tonnage can be ascertained to certain extent. Next slide. Coming to electrical and instrumentation, electrical and instrumentation is also standardized. Only factors are the total links, because it depends upon the layout of the project. So most of the important items for electrical and instrumentation could be ascertained, are standardized, prices are known, so its estimation can be done to some accuracy. The issue is always with the civil and structural items. Next one. Next slide, please. The structural items are actually very much variable, because structural items, this cut-paste theory cannot be governed in uh, any project. It should be tailor-made. The structural items are layout specific. So one layout for Vizag steel plant won't match a layout for a thermal power plant somewhere else. So it's layout specific. It is site specific, because as you know, the sites vary from place to place. And when we speak about site specific, we speak about its wind load analysis, we speak about its coefficient of earthquake, soil specific, and terrain specific. So these are certain items which varies from place to place. And so this cut paste theory of selecting one material from one side will not work for a structural item in any of the projects. So the structural and the civil items are not specific but varies from place to place. These remain as uncertainties. So next one. You see, if we go to the code IS 875 part 3, which is a code for wind load, if you see the red zone, the total east coast is the red zone. So the red zone, and also certain part of northeast. So these colors of green, yellow, blue, red simply identifies that the wind load is not constant all over the country. It varies, and so those copying and pasting will not be effective, and we have to calculate separately for each and every site. Next one. Next one is the earthquake load. So these two loads are site specific. Even here, you find different colors just showing the different zones in India. What does it mean? It means that each and every zone are different in earthquake loading. So here also, nothing can be standardized. It has to be made according to the zone effects of earthquake, the zone effects of wind. Next slide, please. So now what are the issues? Issues in structural steel is the quantity calculation before the project or the designing has been done during the estimation stage. Quantity and thus price becomes a factor. Perhaps 70%, 60 to 70% is mechanical, 10 to 15% is electrical, and the remaining is civil and structural. But the total amount of that remaining for a project is in the tune of, say, 100 crores. So though the quantity or in percentage wise, civil and structural quantity is less, but in volume wise, the price is quite huge. Risky to gauge the variation between the time periods of estimation and implementation, because the estimation is done when the project is in the conceptualization stage. At the project starts, material starts coming in phases. So there is a time difference, a time lag in between prices of materials, especially steel, which is very price sensitive, gives you a run. It changes and the ultimate estimation goes or perhaps might go wayward. So there is uncertainties in estimation. There is no foolproof system of coming to or converging to a fixed estimation for such projects for civil and structural. Next one, please. So these are all what we were speaking is the direct cost. There is another cost which we have not yet considered till now. That is called the life cycle cost, which has not been considered because of the fact that those life cycle cost does not govern a project or the estimation of a project. It gives you the figure for a total life cycle. So this concept is coming in India, but at this moment, we are only interested to the direct cost or the capital cost involved in a project. Next one, please. So objectives. Objectives is how to reduce these uncertainties, how to reduce the assumptions, the estimations in civil and structural during the estimation stage. So we can standardize perhaps certain part of it, but not the total. We can use certain algorithm, but after all, those algorithms are only our tools. Data it is a garbage in, garbage out system. So the data which we include, which we use as an input, must be authentic, but still then there can be variables due to the causes which already I have mentioned. Effective project management and value engineering. These are certain terms, but still it has certain floats in between. So ultimately, what happens is that during the estimate stage, though we can converge some pricing into mechanical and electrical, there might be a total variance in structural and civil items. Next one. And this variance can be reduced perhaps by experienced manpower. That is what I feel. It is the experience of the civil engineer or the structural engineer which can only help in these cases. The AIs or the computers or the Excel sheets are only the tools or the supplies. So the experience of a of a structural engineer or a civil engineer during the estimation stage is quite important. Next one, please. So what happens? We can understand what is now happening. The total framework of engineering, just to find out how much experienced engineers are presently there. So we divide into three categories: the degree engineering colleges, the IITs, NITs, and the other government engineering or the private engineering college. The total number of colleges 6,078. The diploma engineering colleges are around 4,500. These are all taken from AICTE website. And the ITI, Industrial Training Institutes, are 50,000. So what happens? The total degree, diploma, and ITI, the three major arms for a project engineering, the quantities are known to us. Next one, please. We find that there is a shift from core engineering jobs. The degree holders are moving towards the white collar, ambient friendly, non-core jobs. They forget the mechanical, electrical, and civil and move towards some other profession which gives them perhaps much more satisfaction. This is rampant among the undergraduates. Core engineering losing its shine, perhaps, and it is been now undertaken by the diploma holders and the ITIs. So this is the trend which is being followed. If you see any graduate below 40 years, he is perhaps not into this core engineering, but is in some other engineering which gives him much more satisfaction, nor the core engineering. So next one. Coming into the factor, out of this trend of moving out of core engineering, there was an estimate that how much is the employability, the persons, the engineers who are coming out from the engineering colleges, how much suitable or how much percentage of those are suitable for employment. It was found that in 2023, 57% of the total engineers, not only civil, total engineers, be it mechanical, electrical, civil, or any, only 57% are employable. They are employable directly to the industry. Next one. This is a report which is quite alarming, which came out in Economic Times, that less than 8% of the Indian engineers are fit for core engineering roles. Core engineering roles are the mechanical, electrical, and civil. So 8% of the total engineers who are coming out from these degree engineering colleges are really fit for direct recruitment. Next one. So if you see, they have further subdivided, out of which I read the total line: employability of roles like mechanical, design engineers, and civil engineers stand at a meager 5.5% and 6.48% respectively. So for civil engineers, it is only 6.48% respectively. So what to do? So there is a total outflux from core engineering to the other engineering. It has been established. It is now in the print. So it has certain proofs. The only item or only thing which can attract them is perhaps a better job opportunity. If the job, there's always a mismatch, what we understand, what colleges produce, and what industry wants. This is true. This has come to the press. This has gone for debate. And so it cannot be denied. So the only reason or only positive thing which might bring back the engineers to the core engineering, to calculate, to estimate, to negotiate, to find out the actual quantities, to reduce the uncertainties of structural engineering, is if there is a reverse trend from the other items to coming back to core items. So for that, we need to have a better employment situation uh, suitable for them to be attracted for. Next one. So improve job opportunities. That is what I was hinting. We have to improve. Otherwise, there will be a draining out, and that is what is happening. Otherwise, at one point of time, there will be a quite deficit of core engineers who can estimate for the tenders, who can estimate properly with the total background and with the knowledge which is required. So this is what I feel is the crux of this present issue which is haunting us in the civil and structural department. Thank you very much.
Uh, Thank you, Mr. Ghosh. You have you have focused on two very critical issues. One of which is the volatile pricing trend of steel, and really that throws a very serious challenge to the project manager. And the concluding part of your deliberation, that actually surfaced a very critical issue and matter of concern: the lack of emphasis on the core engineering. And that is definitely in the for industrial projects in upcoming years. This situation will pose some more problems, and definitely these all are really sensitive issues to look into, and we believe that we can have more sessions on this, so that in next for the next generation there will be requirement for steel, there will be requirement for power, and there will be projects. So to manage those projects, manage and execute those projects effectively, the resources needs to be developed in a very sensible way, with a holistic planning and approach. Thank you once again, sir, and I request you to be with us for the open discussion and question and answer session. We have our another eminent speaker, Mr. Somnath Bhattacharya, who has joined from Detroit, USA. Mr. Bhattacharya is a very eminent civil and structural engineer, served in many organizations in from design engineering position to project manager to business unit head. He has served in NICO projects, he has served in development consultant, in Tata Consulting Engineers, where I had the privilege of being his colleague, and he has also served as the location head for MNC company like Mott McDonald. And he has been involved in various sectors, industrial sector, right from thermal power to steel, oil and gas, and petrochemical. May I now request Mr. Bhattacharya to kindly share his thoughts with us.
Thank you. Thank you, Mr. Anirvan. Please present my PPT.
পল্লব পিপিটি দেখাও।
Pallab, can you please help? Yeah.
Okay.
Thank you, Pallab.
Good
Mr.
evening.
Bhattacharya, over to you.
Yeah. Good evening, everybody. Though it's morning for me, anyway. I'm in this project management market for almost. Next slide, please. Next one. I'm having experience of more than 40 years in project management in different, there's the chemical, oil and gas, steel, power sectors. And my best project was the raw material handling plant for Durgapur steel plant modernization. It was my lifetime mega project. The equipment, this mega project had the equipment tonnage of 40,000 tons, civil 1,40,000 cubic meter, structural 30,000 ton, and number of conveyors are 212, and there are 13 giant stockyard machines. I elaborate from my experience what are the stages of any project typical in coal handling plant. Next, first step of any project is tendering. In this, all disciplines except civil structure gets the basis of quantities, stock equipment list, specifications, and decide on a reasonable price to quote by getting suppliers quotation or so. But civil structural estimation becomes main indicator for a competitive overall price, as this has to be done from basics. As such, the project I mentioned above during tendering, there were wide variations in estimation among consultants. Our company took right decision to quote the lower figure done by a turnkey contracting firm and win the tender. So estimation of civil structural part becomes very, very critical to win any project. Next. To achieve a realistic BOQ, we have to first go through the tender documents thoroughly, especially the civil structural part and the tender drawings for a typical coal handling plant. We have to segregate the entire scope to number of junction towers, conveyors in tunnel and gallery with profiles, number of houses like crusher house, screen house, etc. There may be large coal bunkers and rapid loading system for mines modernization. For each unit, we have to perform tentative design to get the quantities. In this step, we have to do some adjustment or application from our experience to get a realistic quantities unit-wise. After doing so, we have to go back to entire tender documents to check whether all units are considered or not, or whether any special design conditions missed out or not. One very important part of the tender document is the geotechnical investigation report. Next. The recommendation part of that report to be thoroughly studied. If piling is recommended, then number of piles along with the type of piles to be assessed for each unit. Once the BOQ is finalized, after thorough review, the rates to be obtained from market as well as the site along with local prices and of sand, stone, sheets, etc. Thus, we will be able to fix a realistic price for civil structure. After winning the tender, most important activity is to prepare a control estimate, as during tendering stage, there are always some agreed variations in scope. Considering all these minutes of discussion, previous estimate to be revisited and each unit to be re-estimated from basics to finalize the control estimate, which will be the basis of controlling the project throughout its life. Next. Next step is to prepare an exhaustive civil structural design philosophy and place to customers consultant for approval. This is very important that there may be some difference of opinion between the designer and the approving authority regarding clause of any standard or some factors as per standard. For example, for wind load factors K1, K2, K3, etc. as per IS 875, Section 12 of IS 800, 207, 2007 to be followed or not. All these to be sorted out and agreed upon at this stage itself. Once the design philosophy is approved, the design engineering team to start with the civil structural design based on the assignment drawings provided by the technology engineering group. I want to talk on little more on design. The software generally used is StatPro. Steps for modeling the unit and complete entire input file design parameters, etc. And software is run to get the output. Next. Here I suggest to go through the output and find the elements or members where stress ratios are very low. As such, by few trials of entire process, we have to achieve stress ratio all above 80% as far as possible. For tall structures, deflection check to be carefully reviewed. Thus, we can get an economic design. As to me, design engineering is science of economy. A kg of steel or a cubic meter of concrete excess is a national wastage. This is to be kept in mind. After design is complete and drawings are done, final BOQ shall be computed and compared with the control estimate. If quantity exceeds control estimate, then same shall be reviewed, and if required, entire process shall be repeated. Target shall be 5 to 10% saving with respect to the control estimate. Special attention to be given in the pile design, deciding on type, depth of fixity, etc. Next. Simultaneously, vendors stroke contractors for civil structural execution fixing process shall be initiated. If piling is there, then piling contractor shall be fixed very fast as mobilization time of them and bringing adequate number of rigs takes considerable time. Part CPM and scheduling shall be done for civil structural work in line with overall project schedule. The deep construction shall have to be executed before monsoon. This planning shall be finalized with customer and their consultant interdependently with the customer's activity shall be discussed and finalized along with the quality assurance plan. Ordering of bulk material steel reverse. Next one, please. Ordering of bulk material steel, reverse cement, etc. to be done for 70% of control estimate initially, and as per the project progresses, balance ordering may be done. At this stage, there must be information flow from purchase engineer to the designer on preferred structural sections having commercial advantage so that designer can use those sections. Now, next slide, please. Now, main activities are being shifted to the site, and there should be an internal mission in the organization that any site issue has to be sorted out within 24 hours. This is the most important strategy for success of any project. As such, our team of Durgapur Steel Modernization Project, which I mentioned initially, took oath to achieve this and did that in reality. And this was the key factor of success of the said project. We received high appreciation from our client. This we achieved by mobilizing skeleton design team at Durgapur and organized a mini design office at our site. At site, there will be a lot of issues like mismatches, underground interferences, change in equipment assignment, and lot of others, which are very practical. We solved all such issues sitting at site and working 24 by 7. I I want to mention one example. A major part of coal handling plant of Durgapur steel modernization was committed by our company to be commissioned within a very optimistic date. For that, crashing of almost all activities were called for. During this critical moment, a major flaw in an important technological structure was detected. Immediately, our design team redesigned for continuous 2 days, and drawings were made in material organized, refabricated at site, and erected within 3 days. Thus, we could keep our commitment. That was immense satisfaction to our whole team, and our management recognized and client also appreciated our effort. Another issue of a critical vibration we could solve within a single night by taking only 8 hours shutdown. This the issue was reported at 7 p.m. and we handed over the plant after complete rectification before 6 a.m. next day. That was the spirit. Now I'm going back to main project management. Once the unit is, you can go to next slide. Once the unit is constructed, same shall be handed over to equipment erectors following set protocol. Any clarification raised to be clarified by the civil structural team. For tall buildings, trestles, take-up towers, grouting shall be done immediately after alignment, and uh, final painting of structure can be done after equipment to conveyor installation. Finally, actual civil and structural quantities to be reviewed and compared with the control estimate, and the data shall be preserved for future projects. Analysis to be done whether any extra claim is called for due to any variation with respect to the original order, furnishing same to the main project team to place the composite extra claim to client. Proper support to be given to the project management team during the discussion with the client on the same. Thank you.
Thank you, Mr. Bhattacharya. And you have presented a few challenging case studies. And actually, from the industry veterans like you, these are the learning for us. And I am sure that all the students attending this session will be having some glimpse of the real-time challenges and the way to mitigate those. May I now open the session for question answer and discussion. All the speakers of this panel are present, and we invite questions from the members of the audience, and our speakers are all present to answer your queries.
Hello. My question to Amitava sir.
Yes.
Why the central PSU and state PSU do not insist for optimal structural design in power plant?
Very difficult question to answer, but I would say one of the reasons is the consultant. For a lot of reasons, our consultant, they do not believe in lighter weight. In lighter does not mean unsafe. Safe but lighter weight is possible. But our consultant always go for higher, higher and higher. One of the reasons because their fees also depend on the volume of work. So the factor of safety for our consultant design is normally very high. And if you see the modern trend all over the world, including China, the weight and power is coming down and down and down. But not happening in our country, unfortunately.
Sir, can I ask you?
To add to Mr. Ghosh's answer, I can reply. I have touched that point that STAD output has to be reviewed to have a stress ratio above 80%. That step is never done. And consultant, as Mr. Ghosh said, consultant is satisfied with the first run only. There we never check whether stress ratio is whatever to optimize the structural section. Whatever has been output of the software, we go for that. That is our that is the issue, right? Thank you.
Amitava sir, can you assess? Suppose if we go for optimal design of steel and structure, what amount of steel we could save and what amount of money we could save and what amount of CO2 we could not release?
Well, I would say your first answer to your question, 5% saving of steel rate is very, very normal. I think all the designers will agree that 5% reduction of steel rate is not a great job. But your question will be why that is not done.
Yes.
So I
What
think
amount?
answer is because why the designer will go for best design? Because there is no incentive. You will get the same salary, whether the weight is high or low. But if there is an incentive, I think they will do that. And 5% steel weight saving means I told a saving of 50,000 crores.
Should I add something here? Can I?
Yeah, please.
Yes, sir. Yes, sir. This is a very
Yeah.
important question.
No,
How
no,
much?
no.
How much steel we could not actually manufacture? How much coal we
No,
could not burn? How much CO2 we could not release? And
those
ultimately,
data probably often I won't be able to give, but the basic thing what we are talking, the structural weight is always high, and whatever stat or any software output we get, we just use that kind of blindly. My experience, because since I come from the shipbuilding background,